Now let's look at some examples of doing trig function graphs. For some of these problems, it's just going to ask you some details about what the graph would look like, but you don't actually have to graph it. This is one of them. It's asking you for the amplitude, period, phase shift, and the vertical shift. Here's where we're going to identify that A, B, D, and C for those 4 different things. The first thing I would notice looking at this is that the B right here is not factored out in the middle. Instead of 2x minus pi over 3, I want to factor the 2 out of this. That means I'm actually dividing both of these by 2. That's going to make this pi over 6. So instead of this, I'm going to write this as 6 sine of 2 times x minus pi over 6 minus 5. Now what that gives me, the amplitude is the absolute value of A, that would be 6. For the period, since this is sine, the period is normally 2 pi. To get the period for this one, we're going to take 2 pi over the B. The B is 2. That means our period is pi. Then for the phase shift, we're looking at the D, which is the number in here. Since that's a minus, that means it's going to move it to the right by pi over 6. And last of all, for the vertical shift, that's the C, which is the number out here. Since that's a minus, that means it's going to move it down by 5 units. Now for this one, the 2 on the outside doesn't affect the period or the phase shift or where the vertical asymptotes are. This would only affect the y values for those 1/4 and 3/4 points. So we don't need to do anything with the 2. The 5 here with the x is going to affect the period. And for tangent, we start out with a period of pi. That means our period for this graph is going to be pi divided by b, or pi divided by 5. There's no phase shift because there's no number added or subtracted on the inside of the parentheses. So then all we have left to do is find the equations of 2 vertical asymptotes. If we look at our normal tangent graph, our vertical asymptotes would be at negative pi over 2 and at pi over 2. To find the new locations of these, we're going to do the same thing with these as we did with our period, which was we divided it by 5. So we're going to take this and divide by 5 and this and divide by 5. That's going to give us negative pi over 10 and positive pi over 10. Now to write these as equations, we just have to write x equals. We'd have x equals negative pi over 10 and x equals positive pi over 10. Now in this one, we're actually wanting to graph it. So we're going to have to figure out the locations of those 5 key points, and then we have a vertical shift. So we'll have to figure out what happens to the y values for our 5 key points also. The x values for our 5 points, we would start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. There's no change in the period here because there's no number in here for b. All we have is a phase shift that's going to the right by pi over 4. That means for our x values, we actually want to add pi over 4 to each of our x values. That's going to make this pi over 4. This is 3 pi over 4. This would be 5 pi over 4. This would be 7 pi over 4. And this would be 9 pi over 4. That's the locations of our 5 key points. Now we also want to think about what's going to happen to our y values. Remember that cosine starts at a maximum and goes down. So normally at this value, our y value would be 1. So here it would be 1, here it would be down to 0, then negative 1, back to 0, and back to positive 1. We're going to take each of these and subtract 1 from it. So our new y values, we're just subtracting 1. That's going to give us a 0, a negative 1, negative 2, a negative 1, and a 0. So now we can just plot our 5 points. These are our x values and these are our y values. So we have pi over 4, 0. We have 3 pi over 4, negative 1. 5 pi over 4, negative 2. 7 pi over 4, negative 1. And 9 pi over 4, 0. That will give us one full period of the graph, and then we would want to go back and label each one of these points. Now let's look at this one. Since this is a cosecant graph, we want to start out by looking at its reciprocal. The reciprocal of cosecant is sine, so actually we want to start out by graphing 2 sine of 3x. So the only thing that we would change in here is we would change this from cosecant to sine. We're going to graph this as our guide graph, and once we have that graph, then we can draw in the cosecant graph. We can start with our period. Normal period of sine is 2 pi, so we're going to take 2 pi and divide it by the b, which is 3. That gives us a period of 2 pi over 3. For our x values, we're going to do the same things to these as what we did to our period, which means we're going to divide by 3. This is still 0. This would be pi over 6, pi over 3, pi, and 2 pi over 3. That's all that's going to happen to our x values since there's no phase shift. For the sine, we can look at this multiplier on the outside. That's going to change the amplitude. The amplitude is going to be 2. There's no reflection since there's no minus, so this just means our maximum y value is 2 and our minimum y value is -2. Now sine, remember, starts at the origin and goes upward from there. We're still going to start at the origin, and we go through a full period in 2 pi over 3. I'm going to start here, and sine starts at the origin and goes up. So it's going to start here, it's going to go up to a maximum point, which is at 2. This is the point pi over 6, 2. Then it's going to come back to the x-axis, makes this point pi over 3, 0. Then it goes down to the minimum. That's going to be the point pi -2, and then back to the x-axis. There are my 5 key points. Now that was my sine graph. What I really wanted to graph was cosecant. Now I want to go back and look at all these places where the sine value is 0. Each of those is going to give me an asymptote for the cosecant graph. So I have one here at x equals 0. I have another one at x equals pi over 3, and a third one at x equals 2 pi over 3. I want to make sure that I put 3 different asymptotes in there so that I can draw in 2 of those U-shaped branches for my cosecant graph. I'm just going to take my sine graph and flip that upwards, and then in this part between these 2 asymptotes, I'm going to start at this point and draw my U going down on either side of that. You might also have questions where it gives you a graph. It's going to tell you what the basic form of it is. So looking at this, you can see that you might have an amplitude change, or you might have a reflection because there might be a negative out in front of the function. There's no period change and no phase shift because there are no extra values in here, but there might be a vertical shift. And this tells you that it either has to be a sine graph or a cosine graph. The first thing I want to look at is whether this looks more like a sine graph or a cosine graph. One thing I want to think about here is that the middle of my graph is right here. This is my minimum point and this is my maximum point. And since I'm starting in the middle and going down, that means it's going to be the graph of a sine function, but it's going to be reflected. That means that I'm going to have a negative out in front. I still don't know what my a is. So I'm going to have y equals negative, then I'm going to put my amplitude in there, and I know this is going to be a sine graph. So at least I've figured out that much. I can figure out my amplitude by looking at the highest point and the lowest point. I want to take the difference between those two and divide that by 2. From -1 all the way up to 3 is 4 units. I want to divide that by 2, so that's going to give me 2. That's my amplitude, so that's the A that's going to go in here. And then the last thing I want to look at is what's happening with the vertical shift. Since my middle is up here, normally my middle would be at the x-axis, so that's actually shifted up by 1. So that means my vertical shift is up 1 unit, which would make this a +1 on the end. That gives me my entire function. I've got the negative, my A is 2, and then sine of x and a +1. Now let's look at this one. This says that it's either a tangent or a cotangent graph. We do have a phase shift because there's a -d in there, and it's also possible that there might be a vertical stretch because of the A on the outside. So first let's figure out whether this is a tangent or a cotangent graph. It's going to be a tangent graph since it's increasing. I want to think about normally where my asymptotes are for the tangent. For normal tangent of x, my asymptotes are at x equals negative pi over 2 and x equals positive pi over 2. If I look at where these asymptotes are, they're at 0 and at pi. So that means that they've been shifted over to the right by pi over 2. That means my phase shift is pi over 2 to the right. I'm going to have tangent of x minus pi over 2. Now I still need to figure out if there's a vertical stretch. For that, I'm going to look at my quarter point and my 3/4 point. And for this, I'm looking at the y values. Normally at the quarter and the 3/4 points, these are -1 and +1. Since they're -2 and +2, that means my a must be 2. That gives me the final answer that I needed, and this is 2 times the tangent of x minus pi over 2. But one thing to remember with these, if you've got a problem like this where they give you a graph and you're trying to find the equation for it, you can use your calculator to help you check that what you've got is right. Make sure your calculator's in radian mode for this. I'm going to put in 2 tangent of x minus pi over 2, and I'm going to do this with my Zoom Trig. What I want to check is that it's the same as this graph as to where the asymptotes are and where those quarter and 3/4 points are. So in this one, my asymptotes were at 0 and at pi. I just want to make sure that this asymptote that I can see right here is at pi. If I do a trace with this and I put in pi for x, if that's where there's an asymptote, it should give me a blank for the y value. And yes, it did. So that's telling me that yes, there's an asymptote at pi, and that's what I wanted to have. The other thing I can check is the y values for my quarter and 3/4 points. I'm still in my trace. I can put in pi over 4 for x, and if I did this correctly, I should get -2 for the y. I can also put in my 3/4 point, which was 3 pi over 4, and that gives me a y value of 2, and that's what that was supposed to be. So that's a nice way you can use your calculator just to check and see if you've got the right graph.